A large-scale overnight strike has led to a major fire and cascading power failure at the Luch thermal power plant in the Russian city of Belgrad, where temperatures had fallen to -13 Fahrenheit amid severe winter conditions. According to operational accounts from the scene, the incident began shortly before midnight, when gas turbines and transformers at the facility ignited following a series of incoming attacks that penetrated the city's layered air defense network. The blaze rapidly spread through critical sections of the plant, triggering a collapse of the local grid and subsequent regional outages. The escalation unfolded only hours after Russia launched a significant wave of 200 Shahed drones and 25 Iskander and Kh-101 missiles toward Ukraine's power infrastructure from positions near Bryansk. Russian Air Defense Command in Belgrad had assessed its own territory as secure, relying on overlapping Pantsir and S-400 coverage. However, in the deep cold, the Luch plant's continuously heated turbines produced strong thermal signatures that were visible on satellite and airborne sensors, leaving the facility exposed. Ukrainian forces initiated a complex, multi-phase operation aimed at degrading Russian air defenses before striking the plant. A Ukrainian drone operating 15 miles south of Belgrad identified two major thermal hotspots at the turbine hall. Military planners determined that a direct approach would be detected immediately, prompting the decision to divert Russian attention by targeting radar and air defense assets elsewhere. This marked the opening phase of Ukraine's broader effort to create a temporary blind spot in Russia's defensive network. At the same time, Russian units near Bryansk were preparing to support continued missile launches, unaware that Ukrainian sea drones were moving through forested routes toward radar installations associated with those sites. As the blizzard intensified, both sides confronted extremely challenging conditions, with visibility reduced and temperatures affecting mechanical and electronic systems. Despite this, Ukraine proceeded with a coordinated attempt to disable key components of Russia's surveillance and interception capability well before the strike on the Luch plant. The situation in Belgrad deteriorated further, as portions of the local grid failed under the strain of the thermal plant's collapse. Emergency lights within Russian command bunkers showed multiple system losses in rapid succession, signaling what sources described as a full cascade failure affecting both power generation and distribution infrastructure. Early assessments indicated extensive structural and mechanical damage across the plant, as well as disruptions affecting substations miles from the initial blast zone. More details on the sequence of attacks, the responses from Russian air defense units, and the second and third phases of the Ukrainian operation will follow in Part 2. To stay updated on this developing story, consider subscribing for further reports. Operational data from the overnight engagement indicates that Ukrainian forces initiated the second phase of their operation at approximately 10:15 p.m., deploying 50 specialized drones designed to home in on active radar emissions. These anti-radiation platforms, programmed to track the high-power pulses of Russian S-400 systems, targeted launch and detection sites near the Bryansk region of western Russia. Russian crews at a Pantsir S-1 position first reported irregular signals before their electronic warfare indicators registered simultaneous radiation locks. This triggered an immediate defensive response, with cannon and missile systems attempting to intercept the incoming swarm in extremely low visibility conditions. Despite initial Russian success in destroying a portion of the attacking drones, Ukrainian forces achieved a central objective, forcing Russian command to reallocate two Pantsir batteries away from Belgrad's defensive perimeter. According to battlefield telemetry reviewed by officers at the Belgar Air Defense Headquarters, Russian command incorrectly assessed the incoming wave as a threat to long-range missile launchers positioned in the north. This misinterpretation led to a partial thinning of air defense coverage surrounding the Luch thermal power plant. The immediate aftermath of the drone engagement coincided with a blizzard that severely restricted air operations. Fighter aircraft, including Su-35 and MiG-31 units stationed at nearby airfields in Russia, were unable to take off due to frozen runways and ineffective de-icing efforts. Technical logs from air defense crews indicated that ultra-low temperatures affected radar performance and slowed turret servos on Pantsir systems, reducing their ability to track small, fast-moving drones. At approximately 11:30 p.m., a second Ukrainian strike wave consisting of nearly 90 FPV and loitering drones entered the Belgrad air defense zone. Russian cannon fire intercepted a significant number, but around 30 drones reached the Luch plant. Their impacts damaged outer structures, including roofing panels and control room windows, creating openings that expose the turbine hall's interior. At this point, Russian command assessed the attack as a limited harassment action, unaware that Ukrainian forces were refining targeting data for precision weapons. The primary strike began shortly afterward, when 10 long-range Flamingo-type cruise missiles were launched alongside guided rockets from a HIMARS system operating close to the international border with Ukraine. Thermal imaging feeds within the Ukrainian command vehicle confirmed the turbine hall's coordinates before launch. Russian air defense units engaged manually using thermal sights, reporting limited visibility due to heavy snowfall. While some missiles and rockets were intercepted, the remaining projectiles impacted the reinforced roof of the turbine hall, using shaped charge warheads to breach multiple layers of steel and concrete. Following the penetrations, several munitions detonated within the turbine chamber, damaging primary gas turbines and rupturing high-pressure lines. As flames spread through the interior, Russian crews reported escalating mechanical failures across power regulation systems. Attempts to re-engage air defense weapons were hampered by depleted missile stores and worsening radar interference. Further developments and the resulting collapse of the regional grid will be detailed in Part 3. Assessment reports following the strike on the Luch thermal power plant describe a rapid escalation of internal damage once the breached turbine hall began to fail. After the initial shaped charge impacts destroyed sections of the primary turbines, residual drones from the earlier waves entered through the openings in the roof structure. Their onboard infrared guidance systems locked onto the extreme heat signatures of ruptured gas lines, directing them toward points of maximum thermal output. One of the strikes triggered a secondary explosion inside a high-pressure manifold, producing a shock wave that, according to local monitoring equipment, was detectable several miles from the facility. The explosion set off a chain reaction across interconnected systems. Fire spread along gas transfer channels toward the transformer field, where multiple oil-cooled units subsequently ignited. Witnesses described vertical plumes of green and orange flame rising above the blizzard conditions, visible even through low visibility. Technical logs from the command bunker showed a rapid succession of faults. Turbine shutdowns, transformer overloads, and system alarms indicating severe structural compromise throughout the plant's generating blocks. Grid operators attempted to stabilize the network as the plant's output collapsed. However, the loss of the 60-megawatt core triggered an automatic redistribution of electrical load to surrounding substations. The sudden spike exceeded safe operating limits, leading to protective shutdowns across the region. According to early analyses, this produced a cascade failure that darkened large sections of the Belgrad area in a matter of minutes. Engineers compared the effect to an overburdened circuit system, in which multiple components tripped simultaneously to prevent further damage. Inside the Air Defense Command Center, personnel continued attempts to re-establish control of defensive assets, but blizzard interference, depleted ammunition, and mechanically slowed turrets hindered further interception efforts. Radio traffic recorded near-constant static, and operators repeatedly reported difficulty distinguishing valid targets amid heavy snow clutter. The combination of environmental conditions and prior system saturation contributed to a limited defensive response during the final phase of the attack. As dawn approached, the fire at the Luch plant continued to burn through collapsed turbine structures and damaged transformer fields. Preliminary engineering assessments indicated that both 30-megawatt turbines were rendered inoperable, with significant deformation to internal components. Experts noted that repairs would require a full rebuild of critical assemblies, estimating outages of several days at minimum. Power disruptions remained widespread, with substations offline and grid balancing operations facing ongoing challenges due to damaged infrastructure. Regional authorities are now evaluating the broader implications of the strike for winter energy stability, as well as the vulnerabilities exposed by concurrent weather conditions and mechanical strain on defense systems. The incident has intensified analysis of how low temperatures, radar limitations, and extended engagements can affect the reliability of air defense networks. The attack also underscores the operational significance of thermal visibility in extreme cold, as well as the consequences of targeted strikes on facilities central to regional power distribution. This concludes the report on the multi-stage overnight operation and its aftermath in Belgrad. For continued coverage of developments in the region and broader conflict-related infrastructure impacts, viewers are encouraged to subscribe for upcoming updates.